Hello, my name is Wesley and I'll talk about the introduction part of this project. Okay, the synopsis of this project is about designing and fabrication of a hand-cranked mandoline. Mandoline are basically a kitchen utensil used to peel any kind of fruit or vegetable that needed to be sliced. In this project, we are developing and improving the performance of the current design and concept. This project requires a lot of skills and research as well as knowledge in a field of such as computer-aided design software, AutoCAD, SolidWorks, and hand tool. A mandoline is certainly one of the necessary tools in the kitchen that can help the process of preparing food. Therefore, this design will go through many processes before becoming the prototype that can achieve the objective of this project. Next, I'll talk about the problem statement of this project. Nowadays, new generation want to almost no manual labor and optimize food. Almost all the food category, from vegetables, fruits to meat, are to be served in the form of slice to make the food more delectable. Most of the chef or housewife want to have a variation style when slicing the food to make the food more attractive to their customer and their family. Next, I'll talk about the project objective. The main purpose of this project is for students to figure out the problem when designing and development of food gear based on quick return mechanism. This project also aims to improve students' skill and knowledge in various fields. Also, by doing this project, will help students to practice before facing a real-time situation about producing and designing a product, which makes students become more independent in researching and gaining new experience as well as expanding their knowledge. Okay, the general objective of this project is to design and fabricate a product based on a quick return mechanism with at least 4 mechanical elements. The specific objective of this project is to achieve the product that can solve the problem statement, investigate different mechanical elements, compare and improving existing product, and know how to solve different problems that occur during designing and fabrication. Now, I'll talk about the project scope. In order for this project to finish, it is required some scope of work and proper plan to be followed so that this project will go through various processes before it is produced. Okay, example of scope of work in this project are literature review, which food slicing machine was invented in order to help decrease the time for food preparation process, especially for chef and housewife. Next is methodology. In methodology, we are required to draw at least 3 concepts of design for hand crank mandoline and then show the design to the lecturer. And then we discuss with the lecturer and choose the best one. And next, the scope work is final concept. After we have the final concept, we need to redraw the final concept using a designing software such as AutoCAD or SolidWorks. After that, we'll move on to the next scope, which is fabrication. In fabrication, we will fabricate the product using a suitable material and appropriate method to produce final product. And after we've done all the fabrication, we will move on to the final scope, which is report and presentation. Thank you. That's all from me.
Hello guys, good afternoon. And today I'm going to present my part in this presentation, which is material used in this prototype construction. So first of all, in this prototype, I'm going to explain about the mandolines, which is this device. This thing we bought it from the supermarket. The reason being that is because the mandoline, it came with various attachments, so you can use it for slicing, dicing, julienning, and grating vegetable or fruits that you want to slice, that you want to use. And another reason is that the material used for this mandoline has been approved safe for food consumption. So that is another reason that we prefer to buy from the supermarket rather than build it ourselves. And then second part is the plywood, which is the 10 millimeter plywood, 10 millimeter thickness plywood, which is this. So this give the great rigidity and strength to support our system here, which is a quick return mechanism and gear. So that is why we use the 10 millimeter thickness plywood. Um, and then for the small thing, which is this linkage, this we use 5 millimeter 5 millimeter thickness of plywood. So because the plywood is easier to shape. Next, we use this 5 millimeter plywood. So because it easier to shape the plywood according to our design, and it's very lightweight and also cheap because we found it at the scrapyard. So there's no need to buy a new material. And then this is 2 by 1 inch of wood. We use this. We collect this from the scrap, and because this is a sturdy material, it can hold the guide so that it cannot move. It cannot move, and it hold the guide steadily. And then next we repurpose the gear that we found from the old household that are already broken. So we repurposing this gear into our prototype. So because of that we can save time with so that we don't have to buy a new pair of gear, and we don't have to spend more time on making this gear. So next material we use this aluminum rod because it is a very lightweight material, and it also acts as a guide for this mandoline to go back and forth without going astray. And then next, we also use the bearing for our flywheel to hold the basically to hold this gear in place. It only allow the rotation movement only. It does not allow any other motion. In addition, we use the bearings so that we can hold this system in place, and the bearing also only allow the system to rotate on the bearing axis, so it cannot move anywhere aside from rotating the flywheel. So our problem statement is we have to design a product that will cut the cost and save time for people to cook. So basically, this our project make it people's life easier. So after identifying our problem, which is a need of product that can slice fruit and vegetable, we began our research for existing product which also satisfy our objective and our problem statement. There are several great products that satisfy the requirement for, which is among the existing product is automatic fruit peeling machine, hand operated orange peeling device, and so on. After analyzing and brainstorming for several sessions among ourselves, we decided to take some concept from the existing product and integrate it into our design. So our design concept is to develop a fruit or a vegetable slicing machine that can operate single-handedly. From the discussion in our group, we translate the concept of the prototype into the drawing paper, and then after the several adjustments, we finalize design into our computer-aided design, which is we use SolidWorks for the computer-aided design. From the CAD, we can confirm whether our prototype can work properly or not using a motion study or motion animation. After that, we start procuring the material from various places that are nearby from our faculty. Using the dimension from the CAD drawing, we then start constructing our base and its supporting frame, which measure 350 mm in length and 150 mm in width, using power tools such as jigsaw, grinder, sander, and so on. Next, we focus on creating the mechanism of our system, which consists of flywheel with a pin of 120 millimeter in diameter and linkage of 140 millimeter with slot. And then the mandolin that we bought earlier, which was modified into so that it can fit according to the design. The aluminum rod was cut into size so that it can act as a guide for the mandolin. Then the quick return mechanism was mounted on the supporting frame that was prepared prior. Lastly, our fruit clamp was created so that it can hold the fruit or vegetable while the mandolin was operated. So basically, we don't have to use our hand to hold the fruit in place. The prototype was then tested for its functionality, and then the machine has to be operated smoothly without any hitch. And lastly, the machine was fully disassembled, and every part of the machine was sanded down using 240 grade use of sandpaper until the surface of our machine is smooth and clean. And finally, our prototype was further adjusted after several tests was conducted with using vegetable and fruits.
Assalamualaikum and a very good evening. Today I'm going to explain about the sketch idea. Firstly, for this project, we are doing sketching idea in order to get the final design of the project. So the first step that we do is doing the first sketch. For the first sketch, we are going through to look for the rough sketch in order to give more ideas and gives another parts that we can assemble in the project. For the second sketch, we agree on our group in order to implement the parts together. However, we still need some modifications on the design so that we can get a smooth and efficient design project. The first part that we design is the basement. The basement will hold all the parts together so that we can assemble it and proceed with another step. So the next one, we are doing the gear and the pinion. For the gear, we are having two type of size, which 8.8 centimeter of the diameter, and the pinion was 8.0 centimeter.
Now, I'm going to talk about the characteristic of spur gears. Usually, spur gears are mounted in series on the parallel shaft in order to achieve the reduction. Now, I'm going to explain about the characteristic of spur gears. Usually, spur gears are mounted in series on the parallel shaft in order to achieve large reductions. It is the most simplest and the most common gear that was used, as it is a very simple gear that we can use for the project. So that is why we choose spur gears, so we can design it easy, and we can implemented it in our project without having any problems.
The next one is the engineering analysis of the gear. Talking about the gear, there will be gear and also the pinion. For the gear, the diameter of the gear will be 88 mm and the number of teeth of the gear will be 70. The next one is the pinion. For the pinion, the diameter of the pinion will be 80 mm and the number of teeth will be 64. Before we implemented it into our project, we are doing the simulation of the gear by using the SolidWorks motion and also the gear generator online. So from there, we can calculate and also we can see how the rotation of the gear and the pinion when it rotates together.
Therefore, in order to increase the strength of the gear, we combine the gear with the crank made by wood. We assemble it together so that it becomes more stronger. Therefore, the rotation of the gear and pinion will be aligned without having any disruption and also will be rotated smoothly. When we know the value of number of teeth and also the diameter of each gear and pinion, we can find the center distance, the circular pitch, diametral pitch, and also the gear ratio.
Therefore, after having some discussion and also the calculation for the gear and the pinion, I concluded that the center diameter will be 84 mm and the gear ratio will be 35:32.
The value of circular pitch will be 3.94 mm and also for the diametral pitch it will be 0.8. As a result, all of us agreed to combine the use of 3D printing and also the wood. So for the gear, we are using it with the results of 3D printing, and also we combine the gear with the wood in order to make it become more stronger. So when it rotates, it do not have any problems and it can rotate smoothly.
Hi, my name is Donnell Aron Dublin, and now I'm going to talk about the engineering analysis for the quick return mechanism. Basically, the quick return mechanism changes the rotary to oscillating motion. Unlike the crank and slider, the forward reciprocating motion is at different rate to the backward stroke. As we can see from the prototype, the linking pin has to travel a much greater distance around the top of the crank circle than the bottom during a full right to left stroke cycle. Since the crank is rotating with constant angular velocity, the result is a left to right return motion being much quicker than the right to the left forward stroke. As you can see here, this is our prototype that have been built, our final project. Actually, the mandoline works and function very well, as you can see here, but there is some problem that we face now, that we don't have the holder. Okay, during building this prototype, we have issue with this linkage, where when we assemble all the part, and this doesn't match and doesn't fit the height that we need, and it's a bit higher. So what we did is we remeasure using the SolidWorks and make it shorter. So this is the outcome after we redesign the prototype in using SolidWorks. The other problem we faced during building this prototype, this shaft have some movement and make the gear miscontact with the driving gear. So what we did is we glued this shaft that connected the flywheel, so the thread of the gear won't move, so it will rotate vertically. And other than that, we add this bearing to the flywheel so it can rotate smoothly. Okay, finally, what we get from this project, we have enhanced our skill using the SolidWorks software to design this prototype. And one more, what we missing from this group is we are lack of mathematical skills. That we need to practice more in calculation so that we can design our prototype better than our current prototype. So hopefully next time in the future, if we have the chance to have a project again, we will improve our prototype to be better than this one, which is we can add holder on the top, so we don't need to hold the fruit to slice the fruit and make our life and work easier. Thank you. That's all from us.